Hi everyone, in this video we're going to go through straight line graphs, so pretty much an overview of the foundations of straight line graphs. We're going to start by talking about, well, what are straight line graphs used for? So they are used every day, in business, in politics, many different things, and there's all different types of graphs. So straight line graphs are pretty much the more basic type of graph, but most things in life can actually be modeled using a graph, but that's something that you can do maybe if you go on to do VCE maths. Anyway, let's make a start. So I thought I would talk about what straight line graphs are used for. So with this graph here, it's showing the distance traveled by a cyclist over 4 hours. And we're going to use this graph to answer the following questions. So before we answer those questions, let's just have a look at the features of this graph. I'm just going to get my highlighter out. So on this horizontal axis, it's labeled as t. So usually we use x and y until we have a context. So a context is, we're applying it to some real life situation. So instead of being x, in this case, it's t. So t for time, and it's measured in hours. So you can see we've got 1 hour, 2 hours, 3 hours, and 4 hours. Then on our y-axis, our vertical axis, we've got distance. So usually we would call that y, our y-axis, again, unless we're applying it to a real life situation. So in this one, we're calling it distance, or if it was using a letter, it would be D for distance. Now, this graph here is a straight line, okay? So we're only looking at straight line graphs. So if you draw a graph and it's not a straight line, you've probably plotted one of your points incorrectly. Now, on that line, and I'm just going to get a different color now, maybe we'll do pink and we'll do a little bit smaller in the thickness. You can see that we've got a bunch of points that cross our grid, okay? So we can easily read them off. And a straight line is basically just a whole bunch of dots put together, and they're called our coordinates. So we'll be looking at them in a little bit more detail, but they just help us read the graph. All right, so for our first question, which is how far is the cyclist traveled after 2 hours? Okay, so on our graph, what we need to do is find the 2, which is here, and then we go up until we hit the graph, and then we go across until we hit the y-axis. So for question A, part 1, our answer is 16 kilometers. All right, then for part 2, 3.5 hours. So here is 3, but 3.5 is obviously halfway between 3 and 4, so 3.5. So we go up and we've hit the line, so then we go across. All right, and this is a little bit harder to see. So as you can tell, we don't have a number here. So we need to work that out, which is a little bit harder. So if I've gone from 24 to 32, that is plus 8. So you can see we've gone up 8 here, and then another 8, and so forth. So if we're going only half the distance to there, we're just going to be adding on 4. So this number here is actually going to be 28. So a little bit harder because we've actually got to read it off the graph, or use our scale to read it off the graph, I should say. All right, so that's 28 kilometers. All right, going now to question B. I'm going to use my highlighter again. This time it's how long does it take for the cyclist to travel 24 kilometers? So this time, instead of going from our horizontal axis, we now go from our y-axis. So actually, I'll leave all that writing up, but I'll do it in a different color. Do it in green. All right, so we find 24, which is here, and then we go across till we hit our line, and then we go down, and we can see it's at 3 hours. So for question B, part 1, 24 kilometers, it's going to take 3 hours. All right, and then part 2, 12 kilometers. So again, it's not written on our scale, but we know that each minor line is 12, not 12, is 4, which makes this one 12. So we go across and then down. Again, no number there, but it's halfway between 1 and 2, so it's going to be 1.5. All right, so remember, you can pause this video at any time to write down your answers, and you can also have a go at doing it without me. So if you feel like you're good enough to do it on your own, then do it, and then you can play the video and check your answers. All right, let's move on to the next question. So here we've got another time versus distance graph. So just showing you here. Excuse me. T hours and distance. Okay, so you can have anything on here. It doesn't have to always be distance and time. And we're looking at a journey over 5 hours. Now this one here is actually made up of 3 different graphs, straight line graphs. We've got one going up here, and I'll do it second part in pink. We've got one here, and we've got one going up here. All right, so they would all have their own rule. So we're going to do rules a bit later on. So 3 different straight line graphs, but they're all straight lines. Okay, so they all, have a rule that is a straight line. Now, if you think about it, what is happening here, this yellow section, let's say it says a cyclist again. All right, so the cyclist is riding, and after 2 hours has reached a distance of 100 kilometers. It's a very fast cyclist. Let's say it's a car drive. So the car is driving. After 2 hours, it's reached 100 kilometers. And at this pink section, what do you think it's happening? So we're actually going to 3 because we can't stop time. Okay, we can't pause time. But the distance isn't increasing. So maybe this car has driven somewhere and then after 100 kilometers stopped. So maybe they're going on a road trip and need a little break. So maybe stop for lunch in that pink section. And then in the blue section, continued on for another, it doesn't really stop. That arrow shows that it keeps going. All right, so let's answer some questions. Apologies for my croaky voice. All right, so we'll stick to green. Okay, so for part 1, we're doing working out the total distance, 2 hours. So we've got t equals 2 going up, and we kind of answered that before, going to be at 100 kilometers. You might like to pause it and have a go at doing these ones on your own. All right, at 3, going up, and then across again, we're at 100 kilometers. And that's okay, because that's a pink line. Remember, we said they probably stopped for lunch. So if you haven't moved anywhere, you're still 100 kilometers from your original starting point. All right, part 3, doing 4 kilometers. So at 4, let's go up, and we're going across. So it's 150 kilometers. And then part 4, 4.5 hours. So 4.5 is here. So we're going to go up and across. And again, we're going to have to work out what this part is here. So we're going up 50 here, plus 50. So half of 50 is 25. So that's going to be plus 25. So 150 plus 25, that point there is 175. All right, moving on to question B. How long does it take to travel? All right, so let's look at, first of all, 50 kilometers. So we need to read it this time from our vertical axis. So we go across till we hit our line and then go down. And I'll just do the answers over here. So that's 1 hour. Part 2, 75 kilometers. All right, so 75 kilometers is, oops, you working for me? Is here. Remember, each minor line is going up by 25. And then we go down. Then halfway between 1 and 2 is 1.5. All right, part 3, 125 kilometers, which is here. So we go across and then down. So halfway between 3 and 4 is 3.5 hours. You could write 3 hours and 30 minutes if you wanted to. And then 200 kilometers up the top. There we go. Let's go across. Now that line, we can see it would go through that point. So we go all the way down, and that's going to be 5 hours. All right. So with these two questions, I started with that so you could see how they're being used. All right. So we kind of started off with questions that are a little bit harder, but sometimes it's easier to understand things if we have a real life context to it. All right. So let's move on to the next part. All right. So how do the coordinates relate to the Cartesian plane? So before I move on, remember what I said here. All these little dots are points on the line. All right, so we call them coordinates. So let me just write that down. So points, I don't know what color I've got, pink. Points on a line or on the Cartesian plane. Now, Cartesian plane is just a fancy word for this grid and the axes. Points on a line or on the Cartesian plane. So I might write that. Coordinates are. Okay. So here I've got how many? 8 points. All right, so 8 points. Sorry, I have to keep pausing to cough. I don't know whether you can tell. All right, and I live right near an airport, so you might be able to hear some planes in the background. All right, so I might enlarge this just to make it a little bit easier to see. So our first point, point A, has the coordinates 2, 3. So how we read the coordinates are they are x and then y. So the x and y, we've got the x axis here and then the y. So your first number, it comes from the x axis. It's kind of like if you were finding treasure on a map. All right, we're just doing it as a grid reference. So we find, and I might do this in blue. All right, x equals 2 and y equals 3. Now, the point you want is if we go up on the x and across on the y, this point here is A. Okay, so it's just a grid reference. We've got x equals 2 and y equals 3. Let's do another one. I'll do the next one in a different color. So for point B, All right, remember we start off with the x value, so x is equal to 4, and y is equal to -3, which is down here. And we go down, and then across till they reach that point there, and that's point B. Now, you don't always have to draw these dotted lines. You'll eventually get to the point where you don't need to do that, but we'll just do a few like that until it gets maybe a little bit too messy that we can't do it anymore. All right, so let's have a look at point C. So C, our x value is 3, so we always read it off our x-axis first, and then y is 0. Now, this is an interesting one because we actually haven't moved, okay, because we stay there on the line. All right, so that is point C. All right, let's see if I can get another lighter colour. There we go, this looks pretty. All right, -1, 1. So x equals -1, y equals 1. So again, going up and across. So this point here is D. Not overlapping just yet, so maybe I can keep going with my colours. All right, so point E, we find x equals -2, which is here, and y equals 5. All right, so we go up and across. So this point here is E. And F. Now I'm going to be colouring one that I've already done with this one, which is annoying. That's all good. Let's do this lighter green. Or do this one. All right, so x equals 0 is also where y is equal to 0. So I've just kind of highlighted the 0 again, and f equals -4. So this time we're on the y-axis there for f. I just realised I didn't highlight f. I'll do f again. All right, so the next 2 points, I might just draw them. So -4, 0. So x equals -4 is here, and 0 is on the line. And then -5, -3, so x equals -5, and -3 is down here. That's h. All right, so we do have another one here, which I'm not going to highlight, but you might like to have a go at doing it on your own first. Just remember, you always read the points x, y. So you find the first number you find on your x-axis. So remember, your x-axis is your horizontal axis. So the first one is 2, and then 5. So we go up and across. All right, so there's A. All right, so I strongly encourage you to do a bit of a pause. I'm going to just get rid of those dotted lines. Now I've got sounds like a raven out in the garden. All right, so pause and have a go at doing it on your own. All right, point B, 1, -2 is here. C, 4, 0, we're on the line. D, -1, 5. -1, 5. E, -1, 0. F, 0, -2. -3, 3. H, -2, -3. All right, so hopefully you're able to do some or all of them. All right, with the next table, we've been given the points, and this time we have to work out the coordinates. So we're going all the way up to K. So just over here, let's list all the letters. All right. So we're kind of working backwards this time. This time we're reading the coordinates off the graph. All right, so let's find A. Here is A. So just going dotted line down to the X. So that's going to be 1. And then a dotted line across to Y. So that's going to be the point 1, 1. For B, going down to your x-axis, so -2, and then across to your y-axis, so we've got 1. All right, C, where are you, C? Okay, going up, so -2, and then across, we're at -1. All right, D, there you are, we're at 1. Going across, -1, oh, we've made a square. All right, E, going down, so it's at 3, and then across, we're also at 3. So you might like to pause now and do the rest on your own. All right, F, 3, across, -2, G, where is G? There we go, -3, and then across, we're at -1. H is on the line, so it's going to be 0 and -3. I is also on the line, so it's going to start with 0, 2. And then J is on the line at x equals 3, so it's 3, 0. And K is at 4, 0. All right, so those last four are a bit harder. They're called our X and Y intercepts, so we're going to be doing them at a later point. All right, so I encourage you probably to pause and have a break, just maybe review what we've done so far before we move on to the next topic. All right, so moving on. Now, we've covered so far why we would use straight lines and also coordinates. And now we're looking at the rules. So if we go back to the very start, this graph here, this line actually has what we call a rule. So it's something that tells us the relationship between X and Y. All right, so moving down. So you can see here, we've got a whole bunch of rules, and we're going to actually be graphing these later. But the question asks, decide whether these points, decide if the given points lie on the graph with the given rule. So we've got a rule here. Let me just highlight it. Oops, not that. All right, so here's a rule, and we've got 2 points here, 2, 4, and 3, 5. So what I might do is actually graph them to show you what that rule is, and then we will work out how we can say, well, is that point on the line or not? Okay, so this is a program I use called Desmos, and it's free. You can just type in Desmos into Google and it'll come up. And it's such a quick way to draw graphs. Okay, so our first one I think was 2x, wasn't it? Okay. So I'm just going to take a screenshot of this. Now, you don't have to do this. I probably should have prepared this earlier, so you didn't have to wait for me to do my screenshots, etc. I don't want it that big. Okay. So we'll be graphing these later again, but I just want to show you, first of all, the line. So this is y equals 2x. All right, so the point's 2, 4. So that means x equals 2. So I might highlight that. X equals 2 and y equals 4. So let's go up and across. And it is on the line. Okay, so we can give that a tick. All right, let's do the next one, 3, 5. So there's 3 and there's 5. And then go up and across. And you'll notice that it's not on the line. All right, so that's just showing you graphically, but if we were doing it by hand, or not using a graph, all we need to do is substitute the point in. So let's have a look at A. So our rule is y equals 2x. So the point, our first one, is 2, 4. So that means x is equal to 2. And let me just do a different color here. And y is equal to 4. All right, and I'm going to just use 2 different colors just so we can substitute them in. Okay, so our rule is y equals 2x. So everywhere I see y, I'm going to put in the number 4. And when I see x, I'm going to put in the number 2. All right, so let's substitute that in. Probably shouldn't have done 2 colors. It's going to take me forever to do. All right, so y we did in green. All right, so 4 is equal to 2 times. All right, so imagine, in algebra, there's an imaginary multiply sign between that 2 and the x. And our x value is 2. Yeah, next one I'm not going to do 2 different colors. So 4 equals 2 times 2 is also 4. So if your left-hand side equals your right-hand side, they're on the line. All right, let's have a look at the other point. Okay, so for part 2 of question A is the point 3, 5. So that means x is equal to 3, y is equal to 5. And then we just substitute them into our rule again. So y equals 2x. So y is equal to 5, so I'll put 5 in here. X is equal to 3. Does 5 equal 6? No. So I'm going to put a little cross through my equal sign. So it says it's not equal. So it's not on the line. And you can see that from our graph. All right, there's your point 3, 6. All right. Whereas we were checking the point 3, 5. All right, so have a go at doing the rest on your own, or you can keep watching if you like, because I'm going to do them anyway. But we're just going to test by doing this substitution. All right, so for question B, all right, and I haven't left much room to do these answers, so we might not do every single one. I might just put the answers up the top. So 3x minus 1. So for the first one, we're checking if the point 1, 1. All right, so over here, 1, 1 is on the line. So that's x equals 1, and y is also equal to 1. So I just substitute them into the rule. All right, so 3 times 1 is 3, minus 1 is 2. So 1 is not equal to 2. So that point is not on your line. Then we do the same with question part 2. I just realized I wrote part 2 here. That should be part 1. All right, so for part 2, the point is 2, 5. So that means x equals 2 and y equals 5. So we're going to have 5 equals 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. So 5 equals 5. So that is on the graph. All right, so with the rest of them, I want you to do this working out to check. And once you've done that, you can unpause. All right, so pause while you're doing that and just check your answers. And I'll just do a tick and a cross. All right, so I've just quickly done them in my head, so I'm hoping they're okay. So a cross just means it's not on the line, and a tick means it is on the line. So if you need to pause just to check, please do. All right, moving on. Okay, so the rule, make this a bit bigger. The rule for a straight line, okay, is always in the form y. I shouldn't say always in the form, but at year 8, you'll always see it in this form. Y equals some number times x plus some other number. So if we go back to all the rules we had here, you will see they're pretty much written in that form. They can be negative, so where I had a positive here, you could also have a negative. Okay, so I might just put that underneath. You could also have a negative. Your gradient can be positive or negative, and your y-intercept can be positive or negative. So for all these rules we had here, and we're going to have a look at them again later, they all have a gradient and a y-intercept. And when they're written in this form, you can read straight away what that gradient and the y-intercept are. So the gradient basically is another word for slope. Okay, so if you think about, the ramp you have, which is near the art rooms to get up into the art corridor or into the year 8 rooms. Okay, that has a gradient. It is not a flat surface. So it's kind of, when you think going up like that. All right, so you go from the flat ground, then we go up, and then you can reach the doors going into the art rooms. Okay, so that's what it means by a gradient. All right, so basically you're not on a flat land, so every time you go across, you're actually going up by a little bit. And you could also say you're going down. All right, so if you're walking in this direction, you'll be going down. If you're walking up, your gradient is going up. Anyway, I'm going to get rid of that because that's a terrible drawing. But that's basically what a gradient means. We're no longer on flat ground. We're either going up or down. So we're going to find the gradient and the y-intercept from a table. So a table of values is basically all the points on a line. I'm sorry, I shouldn't say all the points on the line. Some points on the line. So the way we read them is, this is a set of points. And let me do it in different colours, because I love some colours. This is another set of points. It does make the video go longer though, so I apologise. What colour haven't I used yet? This one. I'm liking these pastels. Alright. What else have I got? It's green. And I've got another pretty colour I can use. They're all very bright, aren't they now? Don't want to use light grey. Where's this blue? Yes, I have. Oh, we're going to have to go yellow. All right, so they're all coordinates on the line. So if we just look at question A, Right, so these are all coordinates. So -2, 0, -1, 2, 1, 6, 2, don't know why I wrote this small 2, 2, 8. All right, so they're all points, and we can sketch them if we wanted to. We'll be doing a bit of sketching later, but these will all form a straight line if I was to sketch them. All right, so on your table, you're just reading down like I did there, and -2, 0 is a point, a set of coordinates. Now to work out your gradient, all right, so remember your rule has both a gradient and your y-intercept. Your gradient is basically, well, every time we go up, so every time we go across 1, how much are we going up by? Or we could be going across 1 and we could be going down. All right, so you could have a positive gradient or a negative gradient. So we could either be going up or we could be going down. Now, the way we work that out is we can say, all right, with this first table, and I'm going to take a screenshot because it's a bit tight fitting there. Just want to get that table on its own. Hopefully I can paste it without an issue. All right, so every time, might make that a bit smaller. Every time I go across 1, all right, so I'm adding 1 each time. And all the tables I've given you so far, they do go across by 1. All right, so they do have to go only across by 1. All right, and then what is happening with your y? So we're going from 0 to 2, 2 to 4, 4 to 6, 6 to 8. So we're basically going up by 2, so plus 2 each time. And that's your gradient. So for this first one, the gradient is 2. Now your y-intercept is when x is equal to 0. So because I don't have much room here, I'm going to just write it underneath. So y-intercept is when x is equal to 0. So you just need to find the cell where x is equal to 0, which is here. And what is y equal to? It's equal to 4. So your y-intercept equals 4. So your whole rule, when we substitute the gradient and the y-intercept in, it's going to be y equals 2x plus 4. So if we go back up to the top here, I'm basically just entering the 2 and the 4. All right, let's do the same for the others. Again, you can pause if you feel like you can do this on your own. All right, so for question B, just check that you're going up by 1 each time, which we are. And then what's happening here? We're going up by 3. Now you can do this for any 2 consecutive numbers. So if you're not too confident with your negatives, you can just go from 0 to 1. All right, we're going up by 1. And then -1 to 2, although it's still a negative number there, plus 3. Or you can do it here. All right, so for this one, question B, our gradient is equal to 3. And our y-intercept, remember, is when x equals 0. So we find that, put a circle around it. So it's at -1. So our equation is going to be y equals 3x minus 1. All right, so just substituting in 3 and a 1. All right, remember you can pause at any time to have a go at doing it on your own. Question C, All right, let's have a look at the last two. So going up from 0 to 1, again, we're just adding 1, which is what we want. And then going from 1 to 0, we're actually subtracting 1. So the gradient is -1. And then our y-intercept, find where x equals 0 and circle the corresponding y value. So the y-intercept for that one is 1. So our rule is y equals -1x plus 1. Now we don't tend to write the -1x, so you can just rewrite that as -x plus 1. All right, and then lastly for D, seeing what we're going up or down by. So going from 2 to 0, we're going down by 2. So the gradient is -2. And our y-intercept, where are we? There we go, is at 0, 6. So y-intercept is at 6. So our rule is going to be y equals -2x plus 6. All right. Now, this next section is going to be quite long, so if you feel like you need a little bit of a break, please take one. So what we're going to do is have a look at these different rules, and we're going to sketch them. So you can see we've got a table of values, so we're going to do a table, and then we're going to sketch the graph. So we're going to do all 7 of them. All right, so it's going to be quite time consuming. I also encourage you to do it on your own when you start getting the hang of it. All right, let's start with our first one. I might just put a line in between, so I've got a bit of space. All right, so the first one is y equals 2x. Now, when we're doing a table of values, all right, you can put in whatever you like with your table of values. So if I'm sketching on here, you can see I've got negative values as well as positive, but you don't, on your table of values, you can put absolutely any number in that makes sense, really. You probably wouldn't do 100. So you can start off at 0. It just means when you're sketching, it might not be as straight as if you did some negative values. So I always encourage you to do both negative and positive. So we can go from -3, -2, -1, 0, 1, 2, 3. All right, so going from -3 to +3 just allows us to plot both negative values and positive values on our graph. All right, so just make sure that you do go up by 1. It's just going to be a lot easier to find the y values. All right, to fill in this table, all you need to do is just substitute in one value into your rule. All right, so remember this is our rule here, y equals 2x. You can substitute in -3. You can substitute in -2, -1, 0, 1, 2, or 3. It doesn't really matter. The easiest one, though, is always 0. All right, so substituting in 0 into y equals 2x. So when x is equal to 0, we're going to have y equals 2 times 0. Okay, because remember it's 2x, so 2 times 0. So that's going to be 0. So this point here is going to be 0. Then your gradient is going to tell you how much you're going up or down by. So the gradient of this one, remember it's always the number in front of the x. So if we scroll up to what we did previously, always the number in front of your x. When it's written in this way, okay, but we're only going to be doing it this way in year 8. So the next one is going to be 2, and then it's going to be 4, and this is going to be 6. Now, if you don't believe me, and I'm sure you do, you can just substitute them in. So let's do x equals 3. When x equals 3, y equals 2 times 3, which is 6. But imagine doing that for all of them. All right, so once you know one point, you can fill in the rest. Okay, so if we were going up in that direction, that means we have to go down in the other direction. All right, so I've just filled in that table. Now, all of them, remember, are points on the graph. So I'm going to, just for this one, because I've got the space to do it, the first point is -3, -6. So we find x equals, so we've done this before, x equals -3, which is there, and y equals -6. And then we find the point where they intersect, which is here. All right, you can plot all the points. So the next one is -2, -4. So -2, -4. The next one is -1, -2. Then we've got 0, 0. And you should notice that they form, hopefully, a straight line. If they don't form a straight line, you've probably made a mistake somewhere. And then lastly, 3, 6. All right, so you can see they all form a straight line. So all you need to do now is just, well, try to draw a straight line. You should have a ruler. All right, there it is. And you can keep going. If you've got a ruler, it's a lot easier to do. All right, so it should be a straight line. Okay, so that's how your rule connects with a table, connects with the points, connects with a graph. All right, so moving on to do the others. So the next one is 3x minus 1. All right, so for every table, just go from -3 to 3. Now, here's another hot tip. All right, and remember, we did do this already. Let's go back up to here. When we're doing the y-intercept, remember when it was when x equals 0, and it's the point that is on its own. It's the sorry, I shouldn't say the point. It's the value that is on its own. It's the constant value. So if you can recognize what the constant is, so remember the definition of a constant is a number on its own, which in this case is -1. That means that's going to be -1. You can keep doing this if you want to. Right, so you can get -1 that way, but it will always be the number on its own. So when x equals 0, y is equal to -1. Now our gradient is 3, so that means we're going up by 3 each time. So we're just going to add 3. So -1 plus 3 is 2, and then we're going to have 5, and then 8, and then going down in the other direction. All right, now when you're plotting a straight line, you don't need to plot all the points. So when you're sketching a straight line, you don't need to plot all the points. All you need is 2 points. Now, the best 2 points to use are the 2 on the end. All right, so if you choose 2 points that are close together, it's not going to be as accurate. So I'm going to plot -3, -10, and 3, 8. So -3, -10, -3, -10 is down here. And 3, 8, which is up here. And then you can just draw a straight line going through them. So let's see if I can do a straight line this way. I don't think it's going to work. Oh, maybe it is. There we go. All right, so there's your straight line. I'm going to do that in a different colour. I'll do it in a thicker. Okay. All right, so you just need those 2 points. You can plot the other points, so -2, -7, so you can see that is actually on the line. -1, -4, 0, -1, All right, and you can also say that's your y-intercept where it crosses the y-axis. 1, 2, 2, 5, and then 3, 8. All right, but if you're drawing a straight line, all you need is 2 points. You need to not plot all the points. All right, now going back up here, have a go at doing some on your own. Again, I'm going to do them all. Actually, I'll do them all. Okay, I didn't want this video to be too long, but you can fast forward if you need to. All right, so the next one is y equals 5x minus 3. All right, so we're going -3, -2, -1, 0, 1, 2, 3. Now my y-intercept is -3, so I'm going to put that in where x is equal to 0. And my gradient is 5, so I'm going to go up by 5 each time. And then down by 5. All right, so it's a bit harder to plot the two endpoints because I don't go as far as -18 and I don't go as high as 12. So I'm going to just plot 2 points that I can actually see. So -1 and -8, which is down here, and 2, 7, which is up here. All right, and then you get your ruler. So I'm just going to do a straight line. Going through them. Now your line should go longer than where I've started. Now the dog's barking. Okay, so just drawing your 2 points. Okay, I had to choose, what did I choose? -1, -8, and 2, 7, because the other points on either side, I couldn't fit them on the axes, but that's fine. All you need is 2 points. All right, moving on to the next one. What is that? -2x plus 4. All right, so the y-intercept is 4, so I'm going to put that in underneath x equals 0. And this time we're going down by 2 each time. All right, and I'm going to plot -3, 10, and 3, -2, because they both fit on. So -3, 10 is up here, and 3, -2 is down here. All right, and then just putting a ruler through them. All right, I feel like I'm going through this quite quickly, so just pause if you need 3 minus x. Now this one here, we're used to seeing the x written before the constant. So you can also write this as y equals -x plus 3. Okay, they're the same thing. All right. All right, our y-intercept is 3. It's a constant. And our gradient is -1. So the coefficient of x is our gradient. So we're going down by 1 each time. All right, so again, we need 2 points. I'm just going to choose the 2 points at the end. So -3, 6 is here, and 3, 0 is here. All right, getting a ruler. Now, I kind of want my line to go longer. Can I do that? Yes, I can. There we go. All right, let's make that line thicker so it's a bit easier to see later on. All right, moving on. What's the next one? 10 minus 2x. All right, so again, you can rewrite it with the x first if you want to. Just make sure that coefficient stays with it. Let's do a table where you don't have to start. If we did 0, 1, 2, 3, 4, 5, 6, that's fine as well. So I want always have x equals 0 though, because then you can just put your y-intercept in. It's a bit easier. And we're going down by 2, so 8, 6, 4, 2, 0, negative 2. All right, so we're going to do 0, 10 and 6, negative 2. So 0, 10 is up here. All right, remember that's our y-intercept, and 6, negative 2 is here. Oh, what am I doing? Getting my straight line. All right, I'll make that a little bit thicker. There we go. All right, so there's that line. All right, and one more. Negative 1 minus 2x. All right, you can rewrite that as y equals negative 2x minus 1. And you can start from 0 again. Let's just do that. You really only need 2 points anyway. So, you know, if I was graphing this, I probably wouldn't do a table of values. I would actually just do negative 10 and positive 10, assuming that they fit on the axes as well. All right, so our y-intercept is negative 1. And we're going down by 2 each time. So it's going to be negative 3, negative 5, negative 7, negative 9, negative 11, negative 13. All right, so plotting those points on. So there's your y-intercept. And we can't go as far as 6, negative 13. So I'm going to do 4, negative 9. Just down here. Now those 2 points are far enough apart. Remember, you don't want 2 points that are close together. All right, let's put in our straight line. Might need to move that actually, because I'm not really going through that point. That's good enough. All right. All right, so if you need a break before the next section, please have one, but we're going to go through the x-intercept and the y-intercept. All right, so the x and y-intercept, the word intercept means just where it's intercepting the axes. So you can see here, I might just make it a little bit bigger. All right, our x-intercept is where it crosses our x-axis, and our y-intercept is where it crosses our y-axis. So you can read that sometimes off your graph, or it's basically we just say, well, our x-intercept, so let's just say we can't read it off. Our x-intercept is when y is equal to 0. So, oops. All right, so when y is equal to 0, and we already have looked at the y-intercept a bit. All right, so the y-intercept is when x equals 0. So your y-intercept is where x equals 0. So the y-intercept is easy to work out because it's usually just your constant in your equation, and it will be in year 8, but later on you'll get to more complicated ones. So you can see here our constant is 4, so your y-intercept is 4. But for your x-intercept, you do need to substitute in y equals 0. So it is a little bit harder to do. But as long as you're okay solving equations, you'll be able to find the x-intercept. All right, so how can you calculate the x-intercept and the y-intercept? So, I hate it when that happens. Okay, so your x-intercept, and I just write x-int so we don't have to write the whole word, is when y is equal to 0. And your y-intercept is when x is equal to 0. Now your y-intercept is easy to spot because it'll always be your constant, as long as it's written in this form, your rule's written in this form. So for question A, we've got y equals x plus 1. All right, so we'll do the x-intercept first. So your x-intercept, we're going to let y equal 0. So it means instead of y, we're going to have 0 equals x plus 1. And now it's just an equation you need to solve. So this one's quite easy. You can probably solve it without doing any algebra, but let's do some algebra anyway. What do I add to 1 to get 0? It's going to be -1. Or you can say, all right, let's subtract 1 from both sides. So that goes. And x is equal to, or -1 equals x, or x equals -1. So that means your x-intercept, and you should always write it as coordinates, it's just a good habit to get into, is at -1, 0. Because remember we let y equal 0, so that's why it's 0. So -1, 0. And your y-intercept, all right, you can substitute 0 in if you want, but remember it's always going to be your constant. So that's going to be 0, 1. Okay, just make sure those zeros are there because your x-intercept is on your y-axis, whereas, your x-intercept is on your x-axis where y is equal to 0. All right, so you always have 0 for y for your for your x-intercept, and 0 for x for your y-intercept. All right, let's just do the next one. So B, we've got y equals x minus 4. All right, so we're going to find the x-intercept. So we're going to let y equal 0. So y will always have to be 0 for your x-intercept. So we've got 0 equals x minus 4. And then we just solve that algebraically. So we're going to add 4 to both sides. So the opposite of subtracting 4 is to add 4. All right, so x is equal to 4. So your x-intercept is 4, 0. And your y-intercept, you can just read that straight from your rule, is -4. So it's going to be 0, -4. All right, any stage you feel confident, just pause. And then you can just get the answers. So y equals 2x minus 10. All right, so for this one, we've got two-step equation. So we're going to add 10 to both sides first. So that's going to go. So we've got 10 equals 2x. and then we're going to divide both sides by 2. So x is equal to 5. So your x-intercept is equal to 5, 0, and your y-intercept you can just read straight off, which is -10. So 0, -10. All right, I'd like you to do the rest on your own. I'll write the answers down. All right, but the working out is pretty much the same. All right, and I'll do the full working out as well, so you can check your answers. All right, so there's the answers for D, E, and F. So you can pause that and just correct what you've done. And then we've got G, H, and I.